Okay, this week will be just a slight extension on what you learned last week on how to write a balanced chemical equation. The only thing new is that you're going to be including what we call phases or states in a chemical equation. Now, of course, remember that these are like notes, so copy this into your notebook, use the space bar to stop and start as needed. Okay, there are only 4 phases. Yeah, so a table here of them. So we'll complete this table. The first, solid. If something is solid, then we use the symbol S in parentheses, and this is a lowercase s. So for example, sodium chloride, just regular table salt, is a solid. C12H22O11, that's sucrose, regular table sugar, is a solid. Iron is a solid. Notice there's no space between the formula for the compound and the state symbol. Next, liquid. So we use a lowercase l. When I write this on the board, I use a cursive L so it doesn't look like a 1, but that's optional. So for example, water is a liquid. This is ethanol, what you find in alcoholic beverages. It's a liquid. Something is a gas, we use a lowercase g. Ammonia is a gas. Oxygen's a gas. Just a couple of examples. And last, aqueous. Now, if something is aqueous for water, means that the compounds are dissolved in water. So that's all we mean, aqueous. The compound is dissolved in water. We use a lowercase aq for our symbol. And what I did here is I used the solids of sodium chloride and sucrose as an example because those, you can simply dissolve them in water. And so sodium chloride aqueous is just salt water. C12H22O11 aqueous is just sugar water. So anything that dissolves in water, we use the symbol aqueous. But in its pure form, it's going to be a solid, it could be a liquid, it could be a gas. Carbon dioxide is a gas, but it too dissolves in water to form carbonic beverages, carbonated beverages, in which case would be carbon dioxide aqueous. All right, now what I'm going to do is do the first 3 problems that you find in your homework. And the only thing that you need to do here, again, is just to write the balanced chemical equation and including the states. However, rather than you being told specifically what the reactant is and the product, etc., you need to determine how to write the chemical formula based upon how the reaction is described. So let's walk through this one. Gaseous ammonia. Okay, so gaseous ammonia would be simply ammonia gas. Reacts with, so that means that we have something reacting with the ammonia. So reacts with, positive sign, aqueous hydrochloric acid. So aqueous hydrochloric acid. To form, our arrow, remember that the arrow, there's many different ways we can refer to the arrow. We could say these reactants produce, form, make, so be prepared for other terms besides form. To form aqueous ammonium chloride. So to form aqueous ammonium chloride. Now this reaction, if you look at all of the elements, you find it is already balanced. We don't need any coefficients. Now remember, you can stop the recording here and try these 2 and 3 yourself, and then come back and see how you did. But I'll continue on here. When heated, when heated, solid calcium carbonate decomposes to form. So solid calcium carbonate to form, so that means to produce, to make solid calcium oxide and gaseous carbon dioxide. So the and plus carbon dioxide. So when heated, calcium carbonate decomposes. So that's our only reactant. Decomposes to form the arrow, solid calcium oxide, and the plus symbol, gaseous carbon dioxide. And this reaction, too, is already balanced. We don't need any other coefficients besides the ones, the implied ones for each. And last, solid barium oxide reacts with, so barium oxide reacts with, so that's going to be plus liquid water. Now you might say, well, water would have to be a liquid. No, remember that water can freeze, and if it was ice, it would be solid, H2OS. Water can also be a gas, steam, or vapor, in which case would be G. So water is kind of unique like that. Not many compounds are commonly found in the three different phases, but water does. To form, so our arrow, aqueous barium hydroxide. And that reaction as well is already balanced. And I give you a little hint here on the homework. The first 10 problems, if you write the chemical formulas correctly, you don't need any other coefficients besides the ones that are implied there. They balance themselves. So when you do the remaining problems, or the numbers 4 through 10, you should find that if you write the chemical formulas correctly, the reaction is already balanced. If you find that it's not balanced, then you've made a mistake in writing your chemical formulas. Okay, that's it for this week.